Just like the base of a power can be a product, the base of a power can also be a quotient. When the base of a power is a quotient, we apply the exponent to both the numerator as well as the denominator. The really common mistake is to only apply the exponent to the numerator, so let's not do that. The power of a quotient rule tells us we need to apply the exponent to both the numerator as well as the denominator. When we look at examples, we can really clearly understand this rule and why that exponent applies to both the numerator and the denominator. R over p raised to the fourth power is r divided by p times r divided by p times r divided by p times r divided by p, which is not just r to the fourth over p, but r to the fourth divided by p to the fourth. There are 4 factors of r in the numerator, 4 factors of p in the denominator. Next example, we have a base that's a quotient, -5 divided by y. When we square that base, we have -5 over y times -5 over y. This is a great example to check your understanding of negative bases. -5 times -5 is -5 squared, which I need to write in parentheses, over y times y over y squared. My numerator will simplify to -5 times -5, positive 25. Positive 25 over y squared is the simplified form of -5 divided by y squared. This rule, just like the power of a product rule, applies when any of the factors are themselves powers. This rule applies when either the numerator or denominator, or both, are themselves powers. When we raise a power to a power, we are multiplying our exponents, the power rule. So numerator, a to the x raised to the n. Power rule, the numerator is a to the x times n. Denominator, b to the y raised to the nth power. Power rule is b to the y times n. Again, we are multiplying our exponents. Let's look at an example. The quotient y to the third divided by x to the fifth, raising that quotient to the fourth power. Y to the third raised to the fourth power is y to the 3 times 4, y to the 12th. X to the fifth raised to the fourth power is x to the 5 times 4, x to the 20th. So power rule for the numerator, power rule for the denominator. This is a great example because the numerator is itself a product. So we're using the product of a power for the numerator. All that means is I'm applying this exponent of 7 to each of the factors in both the numerator and the denominator. A to the third raised to the 7th is a to the 3 times 7, a to the 21st. B to the 7th, so we can think of just directly applying that exponent to b, or we can think b to the 1 times 2, b to the 1st times 7, which is b to the 7th. Denominator as well, c to the 10th raised to the 7th, applying the power rule, multiplying the exponents, 10 times 7 is c to the 70th. Last example. We actually also have a product here in our numerator. We have that coefficient of -1 being raised to the 6th, x squared raised to the 6th, which is x to the 12th. And then the denominator is y to the 7th raised to the 6th. We're going to multiply our exponents there using the power rule. So y to the 42nd. This fully simplified -1 to the 6th, -1 to an even power, -1 times -1 times -1 times -1 times -1 times -1. We know that simplifies to +1. So our final simplified expression is an invisible +1 times x to the 12th divided by y to the 42nd power.